Hi guys, in this video we will learn about ladder diagram or ladder logic. Ladder diagram is commonly referred to as ladder logic. Ladder logic is the most popular language of PLC programming. Because it is a symbolic programming language that resembles electrical schematic drawing. It was designed to replace hardwired relay control systems. Relay logic control was very difficult to design, troubleshoot, and maintain. Only designer could maintain it easily. But for others it was very difficult. In PLC programming, some different languages are used. Some of them are officially recognized by the IEC, International Electrotechnical Commission, in the IEC 61131-3 standard. These languages are ladder diagram, function block diagram, structured text, instruction list, sequential function chart. In this video we will learn about what is ladder diagram. If you're a beginner, then you should start with this language. For more information on PLC languages, see our videos. Ladder diagram is built in the form of horizontal rungs with two vertical rails that represent the electrical connection on relay logic schematics. The rungs allow the programmer to watch, debug, and troubleshoot the logic. Ladder diagram is read from left to right and top to bottom. If the condition of all of the contacts on the left true, the output coils energized. These contacts may refer to physical hardwired inputs to the PLC from physical devices such as push buttons, switches, proximity sensors, actuators, or etc. In ladder logic some basic symbols are used, and these are normally open, normally close, coil, output. Normally open contacts and normally close contacts are used for inputs, and coil is used as output. Normally open contact is normally like an open switch. When its corresponding physical filed input is energized or high, it becomes close contact. And when input de-energized or low, it becomes open. Similarly, normally close contact becomes open contact when its corresponding physical input is energized or high. And when input de-energized or low, normally close contact again becomes close. Here consider the concept of relay. When we apply voltage on its coil, its normally open contact becomes close, and normally close contact becomes open. When all contacts in a rung fulfill the requirement of a single rung, their related coil energized. And if any of the contact does not fulfill the requirement, coil will not be energized. The coil or output of a rung may represent a physical output which operates some device connected to the PLC. To learn programming, we need a laptop or PG or computer. Software for specific brand of PLC. A PLC. A cable for transferring data. You don't need to worry. If you are a beginner and not have these items, then initially we can write our program on a paper. So we need only a paper and a pencil. If you have any software, then you can use it. Many brands offer software and a simulator. Simulator means when you make a program you can test it without a PLC and a cable. Here we are using Simatic Manager, a software of Siemens PLC and its simulator. Consider this is yours paper and you are trying to write a program. Every brand of PLC has these basic symbols. By using these symbols we will try to make a program. When we make a program, first we think about it. What is requirement of a program? How many inputs and outputs are there? And then we give names to inputs and outputs. We call these names as tags. Tag consists of name and the specific input or output address. In Simatic Manager, address could be found in hardware configuration. For address we see the configuration of our physically installed modules. they are configured as same as in our field panel. Here we see our input and output address starting from this address. Okay, now we move forward. Consider an example. We have a switch and we want to control the lamp. If we draw this example in circuit diagram, it would be like this. In this example, power is available at switch, but not able to move forward. Lamp will not be on, because switch is open. When we press the button or close the switch, power move forward. Circuit complete and bulb or lamp on. And when we press the button or open the switch, bulb or lamp off. Now we will convert it into ladder diagram. In our example we have a switch and we want to control the lamp. So, we need an input and an output. First, we place a normally open contact in a rung. And then place a coil. Give a tag of contact and coil. For making a tag, we require a physical address and a name. Here we have already assigned the names and tags of used I/Os. So now our program is complete. You see, how simple is this? Download in a PLC. Here we do not have any PLC. We are testing on a simulator. We can call a simulator as a dummy PLC and a tester. Here we are seeing that. This is our input or switch and this is our output or bulb. And it is off, output coil is not energized. Check when we press the button, bulb on. And when we press button again, bulb or output off. Repeat the program. Check when we press the button, bulb on. And when we press button again, bulb or output off. Consider another example. We have two switches and an output. And our purpose is, when both inputs high, output will be high. If we draw this example in circuit diagram, it would be like this. When we press the buttons or close the switches, power move forward, circuit complete and bulb or lamp on. And when we press the buttons or open the switches, bulb or lamp off. So, let's start to make a program. First, we place two normally open contact in a rung. And then place a coil. Make a tag of contacts and coil. For making a tag, we require a physical address and a name. After giving name, save the program. Download in a PLC. And now we will test the program via simulator. Here we are seeing that bulb is off, output coil is not energized. Check when we press the button 01, bulb will not on. When we press the button 02, bulb will start. And when we press any button, bulb or output stop. Now we move forward. We have two push buttons and a coil. And our purpose is, when any input high, output will be high. If we draw this example in circuit diagram, it would be like this. When we press any buttons or close the switch, power move forward. Circuit complete and bulb or lamp on. And when we press the buttons or open the switches, bulb or lamp off. So, let's start to make a basic program. First, we place two normally open contact in a rung. And then place a coil. Make a tag of contacts and coil. For making a tag, we require a physical address and a name. Save the program. Download in a PLC, and now we will test the program via simulator. Here we are seeing that output is off, output coil is not energized. Check when we press the button 01. Fan start. When we press again the same button, fan stop. When we press the button 02, fan start. And when we press the button again, fan stop. We can make any program depending on process requirement. For example, we want to convert a mathematical formula. Q equals A.B plus A.C into ladder diagram. Here we have 3 inputs and 1 output. Now we make a program. First, we place 2 normally open contact in a rung and a coil. And then make a second branch and place 2 normally open contact. Give them tags. Save the program. Download in a PLC. And now we will test the program via simulator. Here we are seeing that output is off, output coil is not energized. Check when we press the button 01 and button 02. Output energized. Similarly, when we press the button 03 and button 04, output energized. And if we press a single button, output de-energized. If you know the basic concept of digital fundamentals, then it is very easy to learn. If you don't know much, don't worry. Stay here. We will give you the knowledge of digital fundamental. We know that in digital fundamental different gates are used. AND gate, NAND gate, NOT gate, NOR gate, OR gate, XOR gate. Each gate has its own working concept. Detail of each gate will be discussed in next video. In last, consider an example. In this example, we have a tank with 2 sensors, low and high. Low level sensor indicates the empty level of tank, and high level sensor indicates the high level of tank. When we switch on our system, low level sensor sense that tank level is low and it gives the command to pump to start. When pump receives the command from low level sensor, it start running and start filling water in tank. When high level sensor detects the level of water, it gives stop command to pump, and pump stop until detection of low level in tank. We will make a program in ladder logic on this example in our future video. Stay here on channel, wait for next video. Thanks for watching.